Viewers, Wagadaruna taking you through the story for A-level principal mathematics. And this video, we are going to go through the expected response for Senior 5 Paper A end of Term 2 for the year 2025 of Mengo Senior Secondary School. So this video is suitable for students in Senior 5 offering principal mathematics as part of their combination. So these are the papers we hope to upload, and if you don't see your paper here, I encourage you to send it on inbox it to me on my WhatsApp, this very one here, so that we add it on the list and see how other students can also benefit. I've not yet seen for the paper for KCB, that's King's College Budo, St. Mary's Yusubi, St. Joseph Nagalama, and Uganda Matters Namugongo, Nabisunsa, and the rest. So if you are there and you're watching this video and you're from any of those schools, I encourage you to inbox me your paper, and also other schools, provided you did item-based questions. So these are the books I recommend, the ones of math, principal math. There is math paper 1, there are 2 books, and also paper 2. So like I've told you, some of you ask whether there will be 2 papers in math. The assessment mode has not yet been officially released, so whatever schools do, I encourage you to obey them. If schools say, for example, for Mengo says they called it paper A and paper B, it is okay. Others will call it paper 1 and paper 2, it is okay. And others will just set one paper, it is still okay. So for physics, I also have paper 1 and paper 2. And then these are for all level. There is physics volume 2 of 2, which is for senior 3 and senior 4 work. Then the item bank for math and physics. Then subsidiary math, it is 1 book. What I've not included here is the math volume 1 of 2, which is for senior 1 and senior 2. So for any of these books, contact the author on this contact. So we shall begin with section A. Section A says, question 1 says, Timothy and Sharon are in a relationship, but when he tried to ask her age, Sharon just wrote a simple note that add 5 to the value after x to the value of x after solving the equation this. 2 weeks have passed, and now Timothy does not know Sharon's age. This word 2 weeks is key, okay? He is approaching you as a math student today. After 2 weeks, remember that. Please rescue him. So first we shall quote this equation and try to solve for the value of x. So yeah, the first thing to do is to apply the rules of indices here, because 2 to power 2x is the same as 2x to the power 2, to the power x to the power 2. So when I write it like that, I can now so that let y and let b equal to 2 to the power x. Then I substitute for y here and here. Like that. There I've got a quadratic. So now that I've got a quadratic in y, I can easily get the value of y. So using the quadratic formula, so it's better to use quadratic formula because some equations, they may not be factorizable. But this one, because it is about age, it is likely to be factorizable. But to avoid repetition, I encourage you to go straight to the quadratic formula. Then I'll get the 2 values of y. So because this is a negative, it is impossible to be an age. So shall take this, and this one shall say x is undefined. Because you cannot get the value of x if it is a negative. So because it is 2 weeks past, it means that Sharon, they said, add the value of x to 18 and then plus the 2 weeks which have passed. So Sharon's age currently will be 26 years and 2 weeks. And that's what they wanted. Question 2 says, during the installation of electric poles in a straight line, okay, the electrician remembers two coordinates, 1, 11 and -3, -5. But the third coordinate, he doubts the y coordinate, so he has written 6w. Help him obtain the value of w. So yeah, what we need to remember is that these points are in a straight line. If I put here -3, -5, and I put here 1, 11, and I'll put here 6w, all these will be in the straight line, so it will be all points lying on the straight line, the gradient is the same. So I'll come and say that the gradient using these 2 points is this, and using this point and this point, it will be this, then I equate them. So when I equate, I'll realize that I have only one unknown, which is now a little easier. So simplify and make w the subject. And that's what they wanted. Then question 3 says, real numbers have two square roots, have 2 square root values. The same is with SADS. Okay, verify this statement by finding the square root of this. In other words, they want you to find the square root of 7 plus 4 root 3 and to see if it also has 2 values. So you come and say, let the square root be equivalent to a plus b root 3. So this root 3 comes from here. Even if you put an unknown at the end, by comparison to b equal to 3. So that's why it's better you just put root 3 immediately. Then when I square both sides, I'll come up with 7 plus 4 root 3 equal to a squared plus 2ab root 3 plus 3b squared. That is now algebra. Rearrange and then start to compare the ones without a SAD and the ones with a SAD. So the ones with a SAD, here I have 4, here I have 2ab. This is where this is coming from to give you an equation. Then the ones without a SAD, here I have 7, and here I have a squared plus 2 plus 3b squared to give me this. So I have 2 equations and 2 unknowns. Substitute for b and get the value of a. So that is a quadratic equation, but the good thing we only have a to the power 4 and a squared, meaning I can still use the bulldozer method to get the value of a squared, not that word. Because we only have a to the power 4 and a squared, I can say that let y be equal to a squared. It will not become a quadratic formula, that's why I'm able to use a quadratic equation. But here you should know that what I'm getting is y, which is a squared. So the 2 values of a will be that. So now when we put square root on both sides, we shall come up with a equal to plus or minus 2 and a equal to plus or minus root 3. Now remember, they told us, they want us to show that there are only two square root values. Now here already we have 4 values of a. It is not okay. So what you're going to do, this one, because a should not have a root 3, then we shall eliminate this pair and we go with only this pair. So you shall come and say that a cannot be equal to plus or minus root 3. So this is eliminated, so we shall go with this. Therefore, when a is that, b will be equal to plus or minus 2. That means that now the square root can be written in this form, where this is a plus b root 3. So where there is a, I've put there plus or minus 2. Where there is b, I've put plus or minus 1 to give you the 2 values. That means we have shown that the square root of a number with a surd also has two values. Then you can conclude that statement is true. That was question 3. Now we shall go to question 4. Question 4 says, during division of polynomials, it was found out that when this quadratic ax squared plus 3x plus b is divided by x minus 1, the remainder was 16. But when divided by x minus 2, the remainder was 34. Determine the values of a and b and the remainder when divided by the same when we divide the same polynomial by x plus 3. So the polynomial is quadratic, and when you divide by x minus 1, it means that the root is x equal to 1. So substitute for x equal to 1 here to get for this one and equal it to this. What is this side should be the remainder. And in this case, the remainder was given as 16. So here we shall get an equation. Then you also repeat for the when divided by x minus 2, the root is 2. Then put 2 on where there is x and equal it to 34, which is our remainder. Then simplify to get equation 2. Now we have two equations and two unknowns, meaning we can solve these two pairs simultaneously. So when I subtract, I'll be able to eliminate b and remain with only a. Then I'll get a as 5. That is a. Then I also need to get the value of b from either equation 1 or equation 2. So if I choose equation 1, I'll be able to get the value of b as 8. So I can now rewrite my equation as 5x squared plus 3x plus 8, and that's what they wanted. So they also wanted to know when the same polynomial is divided by x plus 3. So when I divide by x plus 3, the root is negative 3, so come and substitute. And that's the answer. So the remainder when divided by x plus 3 will be equal to 44. That was question 4. Question 5. Now these ones are not item based, but this is the format which they chose to use, and many schools have chosen to use that, where section A is computational knowledge and evaluation, and section B is scenario based. So question 5 says, John can differentiate this by rule or principle to obtain this, and it is true, but cannot do it from first principles. Okay, take him through to obtain the same answer. So in short, they want us to differentiate from first principles. So you come and first write the given function, then increment. The first step is to increment both sides, where, in other words, where there is y, replace it with y plus delta y, and where there is x, replace with x plus delta x. The next step is to expand and simplify. When I expand this bracket, I'll come up with this. Then here I've chosen to take this one on this side, that's why we're seeing this. Open brackets completely now, you'll come up with that, then you'll see what cancels. If you look here, this and this can cancel, okay? This and this can cancel, okay? This and this can cancel. So you're going to remain with this, this, and this. Now that, how do you know when to divide both sides by delta x? If you see delta x on each term, which is left, that's when you can go the next step of dividing both sides by delta x to come up with delta y over delta x equal to 10x plus 5 delta x minus 3. After getting that, you have to remember the definition that as delta x tends to 0, the gradient, this is called gradient of the chord, the gradient of the chord tends to the gradient of the tangent. So substitute, it means that where there is delta x, you put 0. And where there is delta x, delta y, delta x, you put there dy dx. And that's what they wanted. Then question 6. We can confidently say that 4 is a perfect square of 2. Then this is a perfect square of a plus b. Okay? What values of p and q will make this a perfect square? So 4 is the perfect square of 2 because 2 squared gives you 4. Okay, this one is a perfect square of this because when I square a plus b, I should get this. So I should look for a form, an expression whereby when I square it, I get this. Because we have degree 4, then the value which the expression should give us the perfect square should be a quadratic in x of degree 2. So when I square it, I get highest as degree 4. So I'll come and say that let this expression be equivalent to this squared. Now, I want you to notice something. Do you see this? Because others would have said, why don't you put ax squared plus bx plus c? I'm not putting because the highest degree of 4 has coefficient of 1. So even if I put here, you'll still be correct, but you'll still find out that a is equal to 1. So it is better to just ignore it. So when I expand this, so what I did, I said this one times the whole of this bracket. I'll come up with this. Then this one times the whole of that bracket. I come up with this. Then lastly, this times the whole of this bracket. I come up with this. Like that. Then from there, I'll need to collect like terms. You realize that this one, we have that and that. That gives us 2. We also have this and this, which gives us this. And we also have this and this, which gives us that. Then the balance will be this, which is here. We shall have this, which is here. We shall have this, which is here. Like that. So there I have simplified. After simplifying, I'll need to rearrange that to put x cubed alone, x power 4 alone, x squared alone, x alone, and constant alone. So here they both have x squared, so I'll put them together to get this. Then I'll now begin to compare. Or you can call it equating coefficients. So when I equate x cubed here, the quotient is 6, and here the quotient is 2b. So I can get the value of b from there. Okay. Next, now that I've got b, I can equate coefficients of x squared. Here it is 13, here it is this, and the good thing I know the value of b. So I can easily get the value of c. So let's do that. So then I'll substitute for b and get the value of c as 2. Then next is to equate coefficients of x alone. If I equate the coefficients of x alone here, I'll be able to get the value of p. So p will be equal to 2bc. And the good thing I know b, I know c, so I can get the value of p. And also when I equate the constants, q is equal to c squared. And I know the value of c, so I can get the value of q, like that. So I'll come here and say, equating coefficients of x, I'll come up with p as 12, and also equating coefficients independent of terms independent of x, that is constant, I'll get 2 equal to c squared, which is 4. And that's what they wanted. Question 7. Daniel, a senior 3 student, pressed his calculator and obtained sine 165 degrees as this. Okay. Now what troubles him is how this can be done without using tables or calculator. And even the answer simplified, but not in decimals. Okay. As an advanced mathematician, guide Daniel. So one, we shall remember that sine 165 is the same as sine 15. From here, 165 is in the second quadrant. If the whole of this is 165, this balance is 15. So sine 165 is the same as sine 15. And sine 15 is equal to sine 145 minus 30. Okay, then we can use the compound angle formula to expand sine 45 minus 30 to give you sine 45 cos 30 minus cos 45 sine 30. Now the good thing, these ones are particular angles, so you can use, but if you have a calculator with a big screen, it will give you easily these sides in case you forgot. Just press sine 45, it will give you this. Press sine 30, it gives you this. Press cos 45, it gives you this, and sine 30, it gives you that. Then I can simplify this to get this. Same LCM, I can give you this. So if you have a calculator with a big screen, actually you can cross-check your answer. You press sine 15, you're going to realize something funny. It will give you this exactly. So calculators with a big screen can help you to cross-check your answer. By big screen, I mean FX991. Yes, the ones with Dell and S.C buttons as yellow. Then question 8, it says, root analysis is a major concept when studying quadratic equations, okay? Without obtaining the roots themselves and stating a valid condition, predict the type of roots in the following equations. So they want to predict whether the roots are real, repeated, or distinct. So for the first equation, b squared minus 4ac will give you, so this is a, this is b, this is c. Substitute for b squared, a 4ac gives you negative. Because it is a negative, it means it has no real roots. The second one, we have to first rearrange in form of a quadratic, then b a is 1, b is negative 7, ac is, we have to take this side to become negative 12. So substitute for b minus 4ac, you come up with 97. So 97 is positive, meaning it has two distinct real roots. Then the third one is that, so we also need to rearrange, take the 20x on the other side. Then a is 25, b is negative 20, and c is 4. So b squared minus 4ac gives you 0, meaning it has repeated roots or repeated real roots. So those were computational evaluation. Now we shall go to scenario based, which were my interests. So item 1 says, U.A.C.E is a senior 5 geography student who analyzed that the road from school gate to his class is given by the equation this. So if this is the gate and this is the class, it has that equation 3x minus y equal to 9. Whereas from his class to the staff room is represented by the equation that. So class to staff room is given by the equation x plus 2y plus 4 equal to 0. He also found out that the school library is located at coordinate 5, 1, located somewhere where we don't know, library. And that the road joining the library to the head teacher's office is elevated. Now here, this is what I changed, because when we say elevated, we bring in the 3-dimensional, which is not okay. So I changed, instead of saying elevated to the horizontal, because horizontal, all these coordinates we do, 2-dimensional are on the horizontal. Now when you say elevated, we bring in the 3D, like with the 3D you did in O-level. I think, remember this one, whereby this angle a line can move from here to here, and they ask for this angle which is elevated to the horizontal. So it was funny. So what I did, I had to remove the word elevated and just said inclined at an angle of approximately 45 with the reference x-axis, so that if I have it is still on one plane. Otherwise, when you bring in 3-dimensional, it's going to become tricky. Unless we covered it, but 3-dimensional is mainly covered under the topic of vectors, where I cover 3-dimensional vectors. So that's what I changed to just maintain the 2-dimensional. Then task: as a mathematics student with the knowledge of geometry, help U.A.C.E to part A, determine the coordinate for the location of his class, and part B, calculate the distance between the library and his class. Then part C, find the perpendicular distance of the library from the road joining his class to the staff room. And part D, obtain the equation that represents the road from the library to the head teacher's office. So part A, we shall need to first make a sketch. That line contains the school gate and the school and the class. The another road contains the class and the staff room. So that is equation 1, this one. Then equation 2, you realize that they intersect at the class. So I can easily get the coordinates of the class by solving simultaneously. So equation 1 times 2 plus equation 2, I'll come up with, so when I add, this gives you 7, this cancels, and this gives you 14. So I have one unknown noun, meaning I can get the value of x. When I get the value of x, I can easily get the value of y from either equation 1 or equation 2. If I choose equation 2, substitute for x and get the value of y. So that means that Kawese's classroom is located at the point with coordinates 2, -3. So that was part A. Part B, calculate the distance between the library and his class. So that is distance between 2 points. Remember, library was with coordinates 5, 1. Now the class is with coordinates 2, -3. So they want the distance between these 2 points. So using those points, I can get the distance being equal to change in x squared plus change in y squared, everything under square root, to give you 15 units. So part C says, find the perpendicular distance of the library from the road joining the class to the staff room. So here, if we go here to the sketch, the sketch was here. The virtual distance of the library, remember the library is 5, 1. And the line joining this class, the staff room is here. So the virtual distance will be from here up to here. The good thing, we know the formula for distance of a point from a line. So that's what we are going to use. So required distance will be this. So what have we done? Remember the equation is x plus 2y plus 4. So what you have done, replace where there is x, put there 5, which is here. Where there is y, put there 1, which is here. Then denominator, I put coefficient of x squared, which is this, and coefficient of y squared, which is that. So the formula is also available in the logbook. Then from there, remember that we don't leave a surd in the denominator. So we have to rationalize to give you that. Then part D, says obtain the equation that represents the road from the library to the head teacher's office. So remember they told us it is inclined at 45 degrees to the reference axis, which is x-axis, meaning that that will be the gradient. Tan 45 will be the gradient of that road. And I already know one point on that road for the library, so I can get the equation given the point and the gradient by equating the expression for gradient to give you the value, to give you the expression which they wanted. So that was item 1. Then item 2 says, Mr. Ongom and his wife usually make a monthly budget on the items to be used by all members in their family. In the coming month of August, he wants to surprise the wife as he has already obtained an expression relating the laws of bread and pineapples as this, where B represents the loaves of bread and X represents the number of pineapples. However, the wife has also prepared something concerning the toothpaste. She is saying that the number of tubes of toothpaste raised to a power of 4. The number of tubes of toothpaste raised to a power of 4 should be less than this. Raised to the power of 4 should be less than that. So now we shall go to item 2. Item 2 says, Mr. Ongom and his wife usually make a monthly budget on items to be used. So now we shall go to item 2. It says, Mr. Ongom and his wife usually make a monthly budget on the items to be used by all the members in their family. In the upcoming month of August, he wants to surprise the wife as he has already obtained an expression relating the loaves of bread and pineapples as this expression, where B represents the number of loaves of bread and X represents the number of pineapples. However, the wife has also prepared something concerning toothpaste. She is saying that the number of tubes of toothpaste raised to a power of 4 raised to the power of 4 should be less than 4,096. They also agreed in the previous months that the cost of a loaf of bread and pineapple can be expressed in terms of roots of quadratic equations whose sum is 6,000 and the product is 8 million. Keeping in mind that a loaf of bread is more expensive than a pineapple. So in short, the value of the value of x should be bigger than the value of b. So task part A, using the knowledge of roots of quadratic equations and completing squares. Help him, Roman 1, determine either the maximum or minimum number of loaves of bread are and the corresponding number of pineapples. And part B, obtain the exact number of tubes of toothpaste to be used in August. And Roman 3, remember the cost, help him to remember the cost of a loaf of bread and a pineapple. And Roman 4, help him to know their total expenditure on bread and pineapples. And part B, with a reason, advise Mr. Ongom and the wife whether they should continue making the budget or stop. So part A was about determining either the maximum or minimum number of loaves of bread and the corresponding number of pineapples. And remember they said by completing squares, so shall go back to this equation and complete squares for that equation. So let's do that. So one, we shall remember to complete squares, we need here a coefficient of 1. So we shall factorize out -3 in this 2 to give you that. Then you can complete squares for this bracket, as you see in the box bracket. This x minus half of this, which is 4, everything squared, minus square of this. That is how they complete squares. Then you can open the box bracket to get that as an expression of b. So there we have completed squares. And for maximum or minimum, this should be equal to 0. So you come up with a x equal to 4 and b equal to 9. Okay, then because this quotient of x squared was negative, then it was a maximum. So we conclude that the number of groups were maximum. We shall go to Roman 2. Roman 2 says, help them obtain the exact number of tubes of toothpaste to be used in August. So the number of toothpaste here, they said that the number of tubes of toothpaste raised to the power of 4 should be less than 4096. So shall come and write that let the number of tubes of toothpaste be equal to y. That means that y raised to the power of 4 should be less than 496. Then we take everything on one side. In inequalities, that's what we do. Then we factorize, because y to the power 4 is the same as y squared, everything raised to the power 2. And this one is the same as 64 squared. So difference of two squares gives us y squared minus 64 and y squared plus 64. After that, you realize that this 64 is also equal to 8 squared. So there's still some difference of two squares, which gives us now y minus 8 and y plus 8 and y squared plus 64. So next is to obtain the range of the solution set. So critical values are y equal to negative 8 and y equal to 8. So we shall come and draw a table of signs. So for values less than before negative 8, it is positive. So here you can choose a number like negative 10. Then for values between this and this, you can choose a number like 0. And for values beyond 8 to be positive, you can choose a number like 10. So because our inequality was less than 0, we're interested in the negative values. So we shall come and conclude that the solution set is that. And the exact number of toothpaste, remember there are no negative number of toothpaste, so we ignore the negatives and we write only the positive possible number of toothpastes. That was Roman 2. Then Roman 3. Roman 3 we shall come and say, it says that help them to remember the cost of a loaf of bread and pineapple. So remember here they told us something that here the cost of a loaf of bread and a pineapple can be expressed in terms of roots of a quadratic equation whose sum is 6,000 and product is 8 million. So sum is that, product is 8 million. So factors will now be 4,000 and 2,000, because when I add these two, I come up with this, and when I multiply the two, I come up with 8 million. But because they told us something about what is more expensive, let's first go back and we see. They told us here that keeping in mind that a loaf of bread is more expensive than a pineapple. So a loaf of bread will take the higher amount. So shall come here and say that cost of a loaf of bread is 4,000 and cost of pineapple is 2,000. That was Roman 3, now we shall go to Roman 4. Roman 4 says, help them to know whether the total expenditure on bread, help them to know their total expenditure on bread and pineapples. So remember here we got the number of pineapples bought and the number of breads bought. Here 9 loaves of bread and 9 loaves of bread and 4 pineapples. And here we have got that each loaf of bread is shillings 4,000 and each pineapple is shillings 2,000. So we can now get to know the total expenditure, which will be shillings 44,000. That was Roman 4. Then part B now said, help them with a reason, advise Mr. Ongom and the wife whether they should continue with making the budget or stop. So here they didn't give us any condition in the scenario which will help us to know whether they should continue or stop. That means that now here, as long as your reasoning is okay, you would get a mark. So here, for me, I prefer to say that they should continue making the budget and reason. The reason is okay. It provides a sense of control and a predictability over their money, or it helps them to live within their means. We are doing that because they didn't give us a reason, a condition. Otherwise, most scenarios, they usually give you a condition which can help you to make a decision. Item 3 says, Coffee is one of the main cash crops in Uganda. During the recent NRM party primaries in Masaka, a contestant suggested that a land of this can be used following the partial fractions of this expression, that the two positive partial fractions should be added and used for growing coffee, and the remaining one, which has the negative sign, meaning it is not for farming but for house construction. Okay, then task part A says express the fraction above into partial fractions. I think let's begin with that. So you shall come and say that for part A, we shall first write that, try to decompose into partial fractions. These are all linear factors, so we shall write A over this plus B over this plus C over that. Equivalent sign should not be forgotten. Then equating the numerator, we shall come up with that. Then we shall now start putting values. Putting x equal to 3. So wherever you see 3, you should put the x. So here we choose any values, but it's better you pick figures which will make some of the terms to cancel. For example, if I see this, if I want to make the whole of this 0, I should put x equal to 3. So it means that this will be 0, this will be 0, and shall remain with only this and that, like that. So left-hand side, we come up with here to be 33 plus 12. The whole of this will be 0. The whole of this will be 0. And here we shall come up with this. So in the end, we come up with C as 1. Then also when I want to make the whole of this 0 and this, I'll put x equal to negative 2 to come up with that expression. Then b will be negative 2. Then putting x equal to negative 3 over 2, here it means I want to make this one 0. I want to make this one 0 and this one, so I'll come up with that, which will give me the value of a as 2. Now that I've got a, b, and c, I can rewrite the given fraction into partial fractions. That was part A. Then part B, they said putting x equal to 5 and put x equal to 5 and obtain real fractions for growing coffee and house construction. So when x is equal to 5, the first fraction is this. So replace x with 5 to give you this, which is positive. Second fraction is this. So put to get a negative fraction. And the third one is this. So put x equal to 5 to get a positive fraction. So now that you have the three fractions, remember they showed us the two positive fractions will be for growing coffee and the negative one will be for house construction. So I can conclude that the fraction for growing coffee is equal to this plus this to give you 17 over 26. And the fraction for house construction is this, which had a negative value, a negative figure. That was part B. Now we shall go to part C, which says, determine the exact land in kilometers squared meant for growing coffee and for house construction. So since we know the fractions and also the total area of the land, we can easily get the area for each. So area for house construction is that, then area for coffee growing is that, and that's what they wanted. Then part D, they've said obtain the remaining land in kilometers, in square kilometers, and with a reason suggests any activity that can be done on it. Still here, they didn't give a reason for us to make a decision, so any reasoning will be okay. So shall come and get the remaining area of the remaining piece of land. So the remaining piece of land is that, and this one is even bigger than most of the countries in the world. So, but anyway, it was a scenario, so we can just ignore the units, because when the units are in kilometers squared, then they become extremely a big area. But okay, so just so that the remaining piece of land can be used for livestock farming, and this is because the manure from the farm can be used as fertilizers. Now shall go to item 4. Item 4 says Alex and Francis are friends that always have daily arguments, starting from the Premier League teams they support, that is Chelsea and Arsenal, respectively. Recently, they were moving around the school and entered a senior 4 classroom where they found an expression on the chalkboard reading sign 3A. Immediately, the argument started when Alex claimed that the handwriting looked familiar, and Francis said it was a lie. They later moved to the next classroom of Senior 3 and found another expression on the whiteboard reading 3 sin A minus 4 sin cubed A. Another argument came up when Francis said that the two statements look different but they mean the same thing. No way, it cannot be. Let's bet on it, Bade, were the statements of Alex. As they were still arguing, Francis received a notification on his phone from BBC News showing that Iran was to launch a nuclear missile over Israel whose speed is given by the expression S, that where S is speed in kilometers per hour, and theta is the angle of projection. Task. Using the knowledge of trigonometry, help these two. Part A, without using calculators or tables, settle the argument where the statements mean the same thing or not. In other words, they wanted to find out whether sine 3a is equal to 3 sine a minus 4 sine cubed a, or they are not equal. So let's begin with the left hand side. Sine 3a is the same as sine a plus sine 2a plus a. Then using compound angle formula, I'll come up with sine 2a cos a plus cos 2a sine a. Then this one, again expanding, this will become 2 sine a cos a, which gives you in the end times cos a to give you 2 sine a cos squared a here. Then this one can be expressed in this form, half angle to give you 2, 1 minus 2 sine squared a. Then change this in terms of sine, it gives you 1 minus sine squared a. And this one opening brackets gives you this. Open the bracket for this, you come up with 2 sine a minus 2 sine cubed a plus this minus that. So realize that some things cancel, this and this gives you 3 sine a, and this gives you minus 4 sine cubed a, which is the same as what was found in the S3 whiteboard. So the two statements are true. That was part A. Then part B, determine the speed of the missile if it is to cover 5 kilometers in 300 minutes. So it is to cover 5 kilometers in 300 minutes. Remember, speed is distance over time, but the time was in hours, so if you have said speed is equal to 5 over 5 to give you 1 kilometer per hour. That was part B. Then part C, calculate the possible angles of projecting the missile in the range 0 to 360 degrees of theta if it is to move at a speed obtained in B above. So from this expression, S is 1, so substitute for S, you'll come up with this. So they want you to solve for theta in this equation. First of all, use half angle to express that in terms of sine so that you get a quadratic in sine theta. Rearrange in form of a quadratic, we shall come up with this. Then you can use the quadratic formula to get the values of sine theta. Arc sine 2/3 gives you these two. Then for this one, we shall come up with these two angles in the given range. So those are the possible values of theta. Then item 5 says Riso Farm, located in Wachiso, is among the best producers of eggs and quality chicken in Uganda. Its managing director, Richard, has also received orders from 3 clients for the next month as illustrated below. This for this client, this client, this client. Then another client, Henry, submitted an order on only cocks for his Kuhinjira ceremony. And he just wrote a mathematical statement to the director reading this. Note that Risu Farm sells a whole chicken, not just part. So it shouldn't be fractions or decimals. Task. Make analysis to enable the client know the cost of one tray of eggs, a cock, and a hen. So that means that they want you to solve these ones simultaneously. So you can let x will be trays of eggs, and this to be number of cocks, and this to be number of hens. Or to be specific, I would have used x to be number of cocks to be specific with this one, but it's still okay. It will still come out. So I'm going to generate 3 equations, one from this, and another one from this, and solve them simultaneously. So those are the first equation, second equation, and third equation. So I'll need to solve these 3 equations simultaneously. So let's begin with the equation 1 multiplied by 6 minus equation 2. So in other words, I'm trying to eliminate x. So when I subtract, x will be eliminated. Here I remain with this, here I remain with this, and here I remain with this. Okay, that is one. Then I also need to eliminate x in a second pair. Can say equation 1 multiplied by 12 minus 3 multiplied by 5. So that x is eliminated, and here I remain with this, here with this, and here this. So that means that I can now solve equation 4 and 5 simultaneously. So here I've chosen to eliminate y and remain with only z. That means that the value of z will be equal to shillings 30,000. Then from either 4 or 5, so I've chosen 5, I can substitute for z and get the value of y. Then from either equation 1 or 2 or 3, see I've chosen equation 1, I can substitute for x and y to get the value. I can substitute for y and z to get the value of x. So x will be equal to that. So that was part A. Then part B, have the director Richard to know the exact number of cocks that Henry wanted. So remember they give us an expression of logarithmic equation. So you have to solve this equation to get the number of cocks. So I'll come and solve that equation. So this is the same as 2 to the power 3, then this 3 can go this side. But I still have different bases, so I need to put them into one base. So this is the same as 1 over log base 2 of x. So I can now let y to be equal to log base 2 of x to give me this. Then I can multiply through by y to get a quadratic equation, which is rearranged. Then I can use the quadratic formula to get the two values of y. So remember, y is equal to this, so come and replace it back here and here. To remove the logarithm, it means that this to power this is equal to this, and this to power this is equal to this. So I'll come up with x equal to 8 or x equal to a half. But remember, they said they sell whole numbers, so we shall eliminate the half and take the 8. That was part B. Then part C says compute the amount that Henry will pay to the director. So Henry, remember, is taking, Henry wants to take X number of cokes, and I've seen that the price of a coke is, let me see here, price of a coke is this, shillings 45,000. Okay, and here we have seen that he has taken 8 cokes. That means I can conclude and say total amount to be 8 times 45 to give you 360,000. So that brings us to the end of this video. Thanks for watching, and be reminded that this video will be on Senior 5 Math BO end of term 2 for Mengo Senior Secondary School. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Also, if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.